Alright, so we got another wall wart to repair. I really don't have to repair it, but I like repairing these. These are kind of interesting to crack open. It's like a little Easter hunt. This one's got an interesting failure mode. It's got parts loose inside. This is for my one of my security cameras, and it powers the camera. Here it is. It's it's a wide voltage range input, and it's an output 12 volts at 2 amps, and it's got all the Chinese safety certifications, so we know it's good, right? But I checked my security cameras today, and I noticed that one of them was showing a picture from 2 days ago at 4 in the morning, and it was a still picture, and nothing was moving. So went out, checked the security camera setup. This is actually it's been in continuous use. I'm gonna guess 5 years, maybe 4, continuous use. And it's survived power outages and voltage spikes or whatever and storms. But 2 days ago I decided to give up the ghost. So we're gonna crack it open, see if it's repairable, and if it is, we'll whack it back into service. Why not? It has an LED light on it to tell it when it's powered up, and when I checked today it was not lit, so I guess that's the source of my problem, why the camera's not working. So I'm going to crack this open now. Okay, so we're it's not a snap together device, is it? Oh, maybe it is. Look at that. Purely snap together. I thought it would be glued. Come on. I want to break you. What the hell's this? Oh, that's silicon. Oh, this ain't looking good. Oh, you know what? There's probably a screw hiding here. That's my problem. Where is it? Right here. Okay, let's remove this screw. Okay. Oh, wow. So the controller IC blew up. You can see right here. It's a one chip solution. And I probably don't have that. If you can, I don't even know if you can read a part number off this thing. Where is? It's not even all here. I can't piece it together to read it. Oh, hang on, let's see if we can read this part number. This goes like this. Where's the rest of it? Let's have a look on this side. Everything looks good. But we'll have to... A swollen cap. I should do that before I actually start playing with it. So let me see if I can read that part number. Part of it is still on the chip body itself. Get a magnifying glass maybe. Can't read that. 6203. Whatever that means. Whew. You know what I could do? I have another one of these on another camera, identical. I could just take the screw out, open it up, read the part number, and that would be the end of the mystery. Let me go do that. Let me check this fuse. Fuse is intact. How about that, eh? Okay, I'm gonna go and grab the other one. Alright, so here's the other one. Let's open her up. Oh, it's got a different chip altogether. Oh no. CRE 6203. Let's write that down. CRE 6203. I doubt I have one of these. This one looks how that one's been cooked. This cap's not bulging though. This one sees a lot of use. This one's even actually been in service longer. What I'm going to do is just check some ESR on these. Maybe it's time to recap these little things if I want to keep them running. Let's see if I can get this in the picture. We've got our ESR meter. Okay, what do we have here? .1. It's high ESR on that one. This little cap here is a 47 at 16. Yeah, that's garbage, that one. 470 at 16. That one's okay. And then we have a 470 at 16. That one's okay. So the two caps on the primary side are high. How do you pronounce that? Fuchsang? Yeah, I'll fix this later. But for now, let's have a look at this one. See, this one's not baked like the other one is. This one has an ESR of nothing. This cap's failed. So that would be the reason why that chip blew, because it was probably getting fed AC or very, very noisy DC. Yeah, that's got nothing there. Nothing at all. So let's check this one. See, that one's not bad. Actually pretty good. So we've got a failed cap, failed controller chip. I'm going to see if I have one of these. I don't think I do. And it's a 6203. I'm going to look up I'm going to look up the data sheet for this if I can. See, that cap's a little high. 470. It's right on the borderline. And that one's a little bit lower. Let me see what I can do about that chip. Okay, so I dug through some chips and I couldn't find a replacement. And I'm not going to put too much effort into this thing, considering what it is. These chips, they have the controller circuitry and the MOSFET all built into one little package, and that's what they use for driving the switch mode power supply. And this is pulse width modulation, and they just put the bare minimum in these things. for the output. They got a diode, a choke, a couple capacitors, and then they got a little feedback circuit. I don't even think they have a TL431. There's nothing on here. You see, they get populated for Zener diodes and stuff, and it's all empty. There's only a resistor, and all these others are empty. So I think this one's done. What I want to find interesting is this cap, how it failed. The cap failed and took out the chip, right? So, ooh, some pressure. See that? I guess we're not going to test this cap. It's not even, look at it, spit some gray juice out at me. You see this? Gray juice. Wow. It was under pressure all right. Surprised it didn't blow the seal or the pressure release. But anyways, it's garbage. We're not doing anything more with it. What I'm going to do is I'm just going to replace it with traditional transformer power pack. This one's 600 milliamps, 12 volts, and I think it's enough to do the business just to run one single little camera. It's a Wi-Fi camera, 720p. That's what I use for that security zone anyway. So I'm going to use that. But onto this one though. This one's interesting as well. I want to look at these caps closer and see. Let's see what we got here. ESR on this one is high. And that's going to fail eventually. 22 microfarads. It should be about half of what it is reading. We're reading 3.4. Let's see. 2.3, 2.4. I'm going to change that cap. It doesn't need to be 400 volts because I'm living in a zone where there's only 120 volts. I don't need this Wart to go up to 240. So I can put a 250 volt cap in here safely, and you know, as long as it never leaves the country, it'll be okay. Let's see what I got here. That one's bad too. That's a 47 at 16. I'll change that one. And I think I remember these ones here were okay. That one's okay. That's the choke. This one's okay. So I'll change those two caps and we'll put this one back in service. And but the other one is a goner. We're going to get rid of it. Let's check this one out. Let's check this one out on my cap bridge. Just want to see what kind of readings we get. So we're down to 19 microfarads, which isn't bad from 22. And we are at an ESR of 5.5 ohms, which is not good. Okay, let's slap a new cap in there. Alright, so I got this back together. I got these two caps changed out, a 47 microfarad. I upgraded the 22 to a 47, and I'm going to just put some silicone on this to stop it from flopping in the wind. Just to hold it down. And provide a little bit of mechanical stability for that cap. I'll assemble that and we'll get this thing back in service. So this should last another 5 years. Let's see, this goes here. I need a cover. Put this back together now. Where did the screws go? I lost the screws. You gotta be kidding. Okay. There we go. Now if we test it, we should have, let's see here, plug it in. Lights on. .12.5 volts. Perfect. So I'll put that back in service, and then we'll be done. Alright, thanks for watching.